Hello student, we know change of base rule in previous lectures. We take the basic example based on the change of base rule which in a MSBT board pattern question paper asks for 4 marks. We have change of base rule in a two form. Are that? Log a to the base b, these two numbers must be different. Then we can shift log a to the base x, log b to the base x. X is any number, you have to simplify, but be sure about that thing, base must be same. Second change of base rule introduce that 1 upon log b to the base a, means we start from number a and base is b, then we can take 1 upon log but interchange the base is a and number is b. So you have to must remind the change of base rule having these two format. Let us start from example. Here log x to the base 2 is there, plus log x to the base 4 is there, plus log x to the base 16 is there, is equal to 7. Here log x to the base 2 is possible, but we know that 4 is the square of 2 and 16 is 2 how much power? It is obviously 4th power. So we can apply the change of base rule part first, that is log a, log b and base is 2 instead of x. Same trick apply for the second term, log x, here log a, log b and base is 2. Now we know that the log x to the base 2 is there. Most probably the 2 can go to this side and we have again log 2 to the base 2 is 1. So that's why 2 into 1 is there. Same trick apply here. 2 raised to 4 is 16. So here 4 gave this side of log and log 2 to the base 2 is 1. So 4 into 1 remain. In this step, we apply the log m raised to n is n log of m. Now, here the 4 is the multiplication, so we have to take the basic 4 is there, 7, 4 are 18. Log 2 to the base 2, so obviously we have derived we take the LCM 4 is there. Be careful, here 4, no, 1 is there, here 2 is there, here 4 is there, here 1 is there. The least common divisor is 4, so we can take 4 log 2 of x plus 2 2s are 4, so 2 get multiplication, 4 get cancelled, that is log x to the base 2 is there is equal to 7 4s are 28. We know that the obviously here the 2 1 2 that is 3 and 4, so we can take the log x to the base 2 common, so we remind that addition of this number must be 7 is equal to 28 remain as the same. We can divide these 7 to the right hand side, we derive answer is 4. Here log x to the base 2 is there and is equal to 4. We convert logarithmic function into exponential form. 2 remain as the same, 4 goes to index and x remain as the same. Therefore, x equal to 16 we derive. In this example, we must study about the important step, that is change of base rule is applied for the second and third term, because 4 and 16s are 4 is the square of 2 and 2's 4th power is 16. Because the base we have to clear and law of indices must be same. Here the change of base rule is applied, x and 4 remain as the same. We change the 2 is base. In this step, very important step is there, 4 is the square of 2. That's why 2 goes to this side and log 2 to the base 2 is 1. In this step also log 16 to the base 2 is there. 2's 4th power is 16. That's why 4 remains as the same. Log 2 to the base 2 is 1. Here I take the LCM method. That is what? 4 is in a divisor, 2 is here is 1, here is 1. If not anything is there, so that's why we take the LCM. So obviously 4 remain here, 4 multiple to this term, 7 into 4, and here 2's are 4, and these 1 remain the coefficient 1. In this step, important thing is that we have to take log x to the base 2 common. That means 4 plus 2 plus 1 is equal to 7. We divide 28 by 7, we derive the 4. We convert logarithmic form in an exponential form. That base is same, answer raised to 4, and number goes to x. So x equal to 16, we derive from this example. Next example obviously asks for the board paper 4 marks question. That is also important and easy also. How? So 1 upon log a to the base b plus 1 upon log a to the base c is equal to 1 upon log a to the base bc. We consider the left hand side, we have to prove that it is equal to our right hand side. So in this example, we know that log m to the base n, we can write 1 upon log n to the base m. That is interchanging of number to the base. So we apply the reverse way. So that's why we derive from these, 1 will get cancelled and we derive the interchange. B is number, A is base. In this term also, here we interchange, A is base and C is number. We know that if base are same, then log m plus log n is equal to log m into n. So that's why here b into c is goes to multiplication and base remain as the same. Again we apply change of base rule, that means same. We have the m and n format. M is equal to bc, n is equal to a. So we can write 1 upon log n to the base m. So we derive 1 upon log a to the base bc. Here we derive the right hand side is exactly 1 upon log a to the base bc. Therefore LH is equal to RHS. 1 upon log a to the base b plus 1 upon log a to the base c is equal to 1 upon log a to the bc. In this example, most probably we have to use the change of base rule second part. We use log m plus log n is equal to log mn. And we derive the final answer in a form of LHS equal to RHS. One more example based on such term. Prove that 1 upon log ABC to the base A plus 1 upon log ABC to the base B plus 1 upon log ABC to the base C is equal to 1. We have to prove LHS equal to RHS. We consider LHS. So we derive 1 upon log ABC to the base A plus 1 upon log ABC to the base B plus 1 upon log ABC to the base C. We have the change of base rule. Log m to the base n is log n to the base m. That is interchanging of base and number in the form of 1 upon. So we apply each and every term. Here base is a, so it goes to number, and ABC goes to base. In the second term, same, one get cancelled and interchange. Here is base goes to number, that is b, and base is ABC. Next example, log c to the base ABC. That also same, derive base goes to number and number goes to base. We observe that in each term, base is ABC. So we easily apply the laws of logarithm. Log m plus log n plus log r is equal to log m and r. So a into b into c, we derive ABC and base is same ABC. We most probably know that log m to the base m is equal to 1. That's why log ABC to the base ABC is 1. So we derive RH is equal to 1. Hence we prove that 1 upon log ABC to the base A plus 1 upon log ABC to the base B plus 1 upon log ABC to the base C is exactly 1. Observe that we apply these laws of logarithm in a change of base rule form because ABC number is same and 1 upon that numbers are possible in a base also. That's why we have to apply the change of base rule here. And in this example, we take the addition law of logarithm, that is log m plus log n plus log r is equal to log m n r. Be careful about this formula and apply for simplification. We derive the final answer. Let us try from some example based on change of base rule again. Show that log 5 to the base 2 upon log 3 to the base 2 minus log 5 to the base 6 upon log 3 to the base 6 is equal to 0. We have to show that this term equal to exact 0. We not directly cancel. That's why we consider both the terms. We know that log a to the base b is equal to log a to the base e upon log b to the base e. That means we have to change these base based on our simplest step of the example. Here e I give the general term. We observe that these base are same in this first term and this is same. So we can directly apply. These will get cancelled and we derive the log 5 to the base 3 and log 5 to the base 3 because a and b remain in the number and base. We know that log 5 to the base 3 minus log 5 to the base 3 will get cancelled because positive negative get cancelled. We derive answer is 0. So we derive the final answer log 5 to the base 2 upon log 3 to the base 2 minus log 5 to the base 6 upon log 3 to the base 6 equal to 0. In these example, important thing is that if minus sign is there, you have not cancel the each and term. We have to use the change of base rule in the form of log a to the base b is equal to log a to the base e log b to the base e. Here be careful, e applicable or x is applicable. We have to put any value to the same base of the numerator and denominator of logarithm. You see, in this picture, what exactly? Think about that. In this picture, you see some keys is there. Obviously, it is a calculator pictures. Most probably, 10 raised to x and e raised to x are exponential function. Here base is 10, here base is e. And log key is obviously, if log have the base 10, then it is log, and log have base e, that is called ln. Be careful about this step. If log have the base e, then it is called ln, and log have the base 10, it is called log, and 10 raised to x and e raised to x are the exponential function or power function have base 10 and base e. We can also find the values of common logarithm of positive number with a calculator by keying in log 5 exe gives the 0.69897 value. Always remind that you have to press the previous picture, that is you have to press the log 5 and answer. We derive the value from this calculator, that is 0.69897. We consider the approximate 4 digit in the answer to derive the value of logarithm. So that's why we can also find the values of common logarithm of positive number with calculator.